So the course topics. So what we're going to do today is introduction to DevOps and its necessities. Then we understand what are the components that get into the creation of a DevOps infrastructure. We understand the module 3. We would understand the automated installations and deployment. For module 4, we understand what are the performance aspects and basic security for infrastructure. Module 5, we get into the scripting and language Python. 7, we understand the virtualization and its concept. We understand in module 7 what are the monitoring and logging, and the various DevOps tools and commands that would actually create this whole infrastructure, and as well as the skills that would need to be for each one of these courses. So objective, understand DevOps for this particular module, its role and necessities. Know about DevOps problem and solutions. Make DevOps transition. How do you adopt a transition for DevOps? Learn to identify cultural impediments and overcome it. Understand about building accountability and trust. Understand your infrastructure layout and its challenges. Learn about scalability. Learn how networking, the whole concept of networking fits into this DevOps framework. So this is the agenda for this particular module, and let's see how we go about doing each one of them. Okay, so the unique problem which we all have and we've all faced as part of infrastructure engineers or developers as we have been in the past. Now, developers always look for a change. See, in today's scenario, everything needs to be in a very active way. Like businesses come back and say that they want a particular feature to be started, to be launched in just a week or 2 weeks and things like that. Now, this has not been the case earlier. Everything we used to take a lot of time on how to go about doing it. So now this has not been the case as such. So developers always look for changes. They try to implement every new techniques introduced. Whereas operations say change is the enemy for operations and is not reliable and leads to instability. Now, where does the DevOps going to come and fit in? And was DevOps earlier there to solve these problems? See, now much before this word DevOps came in, we already had automation or the word was automation then at various levels. I mean, if you just go back in time, we always had this network interface cards which came with a option to install over the network. Now, this existed even much before many of these organizations adopted the so-called concept of DevOps. Now, what was that introduction of this network-based installation? So, network-based installation was one of the first attempts to start work in an uninteractive way. So that you don't require a lot of attention of the operators to get some work done. This way, we made sure that we could just need with a click of a few buttons or so, we would get the work done. So this was one of the starting points of the automation that came in. But was automation only at that level? Where do the development aspect come into those kind of automation? So that's what we want to see as we go in a little further. so difficult to integrate, so DevOps problems, so difficult to integrate tools, very less interest in learning other tools, different implementation of similar tools. Now, we know that the DevOps, the development tools and operation tools are two different things. And there was never an integration between these two at any point in time. So the dev tools basically comprise your development, your IDEs, your version control system, and the compilation units. Now this is what would constitute your development platform. And then once this is compiled, you would then need to put this particular you need to have this packaged, put into some other place from where which we could source. So if you're kind of familiar with, if you're looking from the Unix background, we had these packaging tools like Yum and RPM, etc., where you had these tools which are kept. And if it was not so much on the Windows side, I mean, Windows also would have an equivalent kind of a tool. So where we could have all these packages installed. And so is the case with the op guys also. So op guys also have their own tools. Now these tools are there primarily to manage these packages that we have built. Example, like if you have your the dev have created their package, and then we need to install them, we need to configure them, and then we need to monitor them. Now, so as you see now very clearly that so there are very clear set of tools for the dev and for the ops. And now how do we integrate them? So that was the question which remained unanswered for quite some time until these bigger, until the web scale kind of architecture had kicked in. So when earlier we were only dealing with maybe 40 servers, 50 servers, 100 servers. So there we didn't have so much of a problem working in an isolated way where devs would do their job and ops would do their job. But when the servers have ranges in thousands, somebody thought about this is not the way to work. Okay, we have to bring in some kind of integration. So that's where this whole thing started about. Development. Now this is the classic case of how the earlier way of operations would work. The development team would send out its code based on the requirement, and then the ops team would then install. The classic case of installing any app. Let's say you're installing Apache. So you download the app, you would install it, then configure it, and then you test this particular app is working or not. So now that's the classic case how it should be. Now, is this okay? Is this the way that we need to work generally? This is the question that would arise as a part of the today's new infrastructure requirements. And is there a way I could bring in some kind of consistency in this kind of operation? So if I were to be doing this for more than 100 systems or so, can this work? Can this really work? So can this really work? So developer gave a faulty artifact, and so whatever was deployed was bad, and then the operation teams wouldn't. So now if you look at the scenario here, now the operation team would not know what could have been the problem. So from his point of view, he will check his parameters. So that would be to check whether all the basic necessities are up and running, like if it's your operating system, check your OS is running, the server, to check if your servers are up, your storages are up, and all that may be required if it's and primarily these are web servers, to check if the web servers are up, if the IP is configured correctly. All these things is, see, only these kind of activities is what the operations people can do. Now, coming to the development side of it, his job is to look into the code assets, and he will not look into any of the operational part here. So, now you see that if these two people were sitting together, there would have been a great synergy. So the dev would know where exactly he can really isolate from the dev side if it's on the code aspect, or operation guy can then check if it's on the operations aspect. So when they both sit together, that's where you get a different scenario of operations, which we've not seen earlier as such. So the developer is working on his machine, but he's facing some firewall issues for a local tool. I mean, this is the basic thing which I was just talking about, whereas he reaches out to a local IT team and they point out to the infrastructure team, and then finally the issue is resolved. So here, how when both of them are sitting together, they are able to handle the situation better, because each one is able to isolate the problem from their respective areas. Operations team will give their analysis on if a problem exists, and the dev team would give their analysis on how it would actually be if it was all working together. Okay, so after deployment, so developer checks in and figures out that the correct DB was not deployed, whereas the operations after deploying during test, after few scenario tests, see some anomalies and raise some defects. So so by now, I mean, you're able to kind of see where each one actually is able to work in their individual space and yet to bring in synergy here. So there is clear, now there is, I mean, I want to emphasize here, there is a clear cut difference between both the people, but they operate in their isolated way, but yet integrated together. So nobody gets into the other's job as such. They are still working on their own way. But what comes into the picture here is the way they operate, and way the operators themselves manage these entire systems. Because scenarios we are looking here is not like the only scenarios where we have 5 servers and 10 servers. We are looking into hundreds of servers. So the way they operate has to be in a different way compared to what they have done previously. Now, yes, if something has gone bad, and then we roll back. So that's the standard procedure in any of these operations. Now, what I want to emphasize here also, imagine if this code had gone to, say, 100 servers, and you want to roll back, and you want to do this in, say, less than 5 minutes, 10 minutes, because if it's web side of it, how many number of people come per minute, right? So how would you do this? Now, this is where the tools come in and change the way the DevOps itself operates. If I want to bring back this in 5 minutes, now can we do this in the traditional way where you go and manually change it, or how do you get this done? So DevOps is not just about operations. It's also about using tools to get these operations in place. Like as I said, rolling back of 100 systems. How do you do this in minutes? Now, We can only achieve this if we do an operation the way is in DevOps and have those tools to get this complete synergy going. Who does the build? Okay, so the build piece still lies with the developer. So the build now, I mean, today even the build piece gets actually automated. So somebody checks into one of the version control system, then it is checked out, compiled, build it into a format, and then pushed it into the provisioning system. So this whole process itself actually gets automated these days. And to do this process of automation, now here when I say process of automation, that is build. When I say build and package and push it into the deployment tool. So most of the time, this is kind of handled. This is normally handled by the developers themselves. But I know of scenarios in bigger organizations. The build automation is also handled by the DevOps engineers as such. They can do the build as well if a requirement arises. But normally, I have not seen cases where the DevOps handle the build. They start from the package. That is, once the package is created and they push it into a deployment tool, like as you said, a YUM or an RPM or whatever. We start from there as such. Okay, now I'm sure with all of these questions and the answers to them, we understand where DevOps is, right? As I again emphasize, development guys continue to be developers, whereas it is the operations guys who are enhancing their skills to meet up to the level of an automation engineer, where he has to imbibe the coding skills so that he can use coding for operations basically, than for actually the application development. So the application development will always lie with the developer. He would not get into the operations in any way, except for fixing up problems and things like that. That is where when they come together. But it is the operations guys who enhances his skills than actually the developers who enhance their skills. But that doesn't stop a developer from coming into the DevOps space. So, but moving into a DevOps space, then what it means is he is leaving his existing dev work and moving towards an operations side of it. I hope this is making clear to everybody now. Okay, so now that we have kind of seen where the whole issue of DevOps and dev and operations are coming together. So let me just read this out for you. So dev is used as a shorthand for developers in particular, but in practice it is even wider, and it means that all people involved in developing the product. That includes your product, QA, packaging, or any other kind of discipline. Whereas ops in a blanket term means systems engineers, administrators, operations staff, release engineers, DBAs, network engineers, security, and various other titles or disciplines that may be. So the word DevOps, I know it confuses, saying that it seems to be that the operations guy will also get into the development and the developer guy gets into the operation. It is not the case. So that's what I was trying to emphasize here a lot. They continue to maintain their individuality, but they work in a more synchronized and more cohesive way together. But what we see here is the ops engineer who from, if you take a lot from a background out here in India, he would mostly be a DBA or a Unix guy or a network guy or a storage. Now, this guy would now need to add in much more skills and more importantly add development skills as well. It's only if he had the development skills is when he is able to automate and he's able to think how to automate. So that's most important here. So we have another 2 more questions. I prefer to answer them. Actually these clears a lot of doubts of so many people. These questions are very interesting as well. So that's why I'm doing a little emphasis on answering the questions as I go through the slides as well. Now, Habib has a question here on the layered products. Is the expectation that DevOps engineers should know OS and also all these middleware technologies? Yeah. Yeah, yes and no. Okay, I'll give you a scenario which I used to work at. Now, does he need to know middleware technologies? Yes, and I'll give you an example. So, I worked in an environment where there were 100 web servers, okay? And I had to ship these log files from these servers and consolidate them in a backend server. See, I know we have other tools like the normal syslog configuration tools and stuff like that. Now, if I had to ship them, I could also use these tools, or also I could write in my own tools. Now, imagine a scenario. I think I could more probably take up the error log message files. I think let me take on that than Apache log. Now, every system creates log messages files in a file. Could be a D message or var log messages. Now, I have to ship them and analyze them. Now, if I had to ship them, I could do the normal systems operation of copying from one machine to another and then get it going. Now, imagine if there are 100 servers and then I'm trying to put this all into a single server. Now, that's not going to work in a right way. And I don't want to ship the entire files as well. I just want to ship only that difference of data which has occurred since my last movement of the data. So how do you do this? Now, you need to have some skills on an MQ for you to read that just generated log and ship it. Okay, so you need to have. So now I wrote this using a RabbitMQ and using a Perl as my tool to take the difference of file, put it into my RabbitMQ server and ship it onto the other end. So yes, so if I ask you, yes, but he does not need to know a WebLogic or a WebSphere app server. He just needs to know any of these open source. And most of the time these are, we today use open source tools to manage all this. Yeah. So again, going back to the question, I think which Kishore asked, yes, do we need to know more? Yes, we need to know more. We need to know OS technology. We need to know middleware technology. We need to know your web technology. We even need to know pretty deep level of networking as well as security. Okay, so of course I'm going to come to the security. Not to deep level, but to some level. But you need to know networking at a pretty decent level compared to what you have probably learned previously. Okay, so now DevOps has a solution. Instead of seeing these two groups as silos who pass things along but don't really work together, DevOps recognizes the interdependency of software development and IT operations and help an organization to produce software and IT services more rapidly with frequent iterations. now we see that there is definitely a requirement for the synergy between these two. So what happens in a DevOps environment? The developers, the operation engineers, and the business team all work together in a more cohesive way than they've ever done before in other environments. So this is the kind of first test towards having more closer integration among all these guys. But again, I need to emphasize here, nobody's getting into others' job, but primarily helping each other to understand their domain better. But more importantly, the operation guy's skill has definitely enhanced to get this whole process in place. That is one point which I need to emphasize here. And also, a developer can get into a DevOps job, a business guy can get into a DevOps job, or a systems guy can get into a DevOps job. So DevOps is definitely a different set of skill sets. I'll come into that a little later on what are the skills and all that. But yes, it's a unique skill set to have, and it has a lot of requirements in terms of how you want to push in all these tools there. Okay, so I think we kind of went through this a little bit. So I guess, and I'm sure you understand now what is DevOps. So DevOps is the practice of operations and development engineers participating together in the entire service life cycle, from design through the development process to the production support. So initially, I mean, people who come from dev background, you know that there was agile development, and you would use a lot of those tools. What happened a little later is, though the people who are agile with the development side of it, they also wanted to bring in equal participation from the operations side towards this agility, and they had this agile administration as such coming in. So we'll talk a little on that as we go along the skills and stuff. Thus, this DevOps was formed. Okay, so I want to re-emphasize here. DevOps is a new requirement which also requires unique set of skills to perform that role. But each organization does that in their own way, which they feel which is appropriate. In a web scale architecture organization or the internet scale company, the internet organizations, the DevOps role is very clear. He's a guy who knows systems and its operations very well, but come with a solid set of but comes with a solid development background, and he knows a lot more tools than generally a system admin would know. When you say a system admin, you look more towards Unixes and servers and storages, but he would have to have things like your SCM, his bit of middleware, bit of DB, and much more, and much more, so that he is able to visualize this. Because you need to have the re-engineering work on this whole system sides of it in a very clear way. So that's how you create a DevOps guy as such. Okay, so the perfect storm, as they say. Now, what was this perfect storm? In the last slide we saw that, right? There was this agile methodology which had come in, and all the development work moved towards this agile methodology. Earlier we had waterfalls and various other methodology. So people moved towards into this agile methodology as such of development. Then these CIOs, if you ever talk to them, they always look at ways to bring down operational cost. Okay, they always find ways to how to bring down the operational cost. Now, to reduce these operational costs, by default, we know that we need to reduce the IT side of cost plus the process side. I mean, when I say the people side of the cost, the process side of the cost, and the technology side of the cost. Now, to get in all these things, we had to re-engineer the whole operations as such, and that is where people start talking of lean IT services. Now, around this time of 2008, 2009, this was a time when cloud was actually booming as well. Though I should emphasize here, DevOps is just not for cloud alone, but it could be for any be for the traditional IT as well. But booming of the cloud and the prominence of Amazon coming in a big way, the agile methodology of development, the tools for automation, then the theory of constraint, how to remove the existing bottlenecks. Like one of the standard examples of removing the bottleneck was, we all know there is a limit per server, right? Now let me take an example of a server which has a Apache web server installed on that. Now, if you look at that server, how do we know how many simultaneous connections can this particular server handle? Okay, so this leads to learning the system's bottlenecks, and this is what theory of constraint is all about. So if I could know how much of simultaneous users that a particular server would handle, then I can size it in a clear way, bring in automation apart from having the agile method. So all this kind of came together around 2009, and that's where this term called DevOps actually started coming in. Prior to DevOps, we had this word called automation, which always existed. So there was this question being asked, do we need to know in depth of OOPS? The answer is yes. Now what's happened is in your scripting world, we did, what is this? So if you generally look at the language as such, we know we could do procedural form of development, functional form of programming, and OOPS way of development. So earlier in our scripting space, we always done the procedural form of development and add some functions in that. Now this would suffice most of the world of scripting automation. But once we get into the world of DevOps, we ought to understand OOPS, and OOPS is used in a very, very big way in DevOps. So we don't have an escape from that. We don't have an escape from that. So so what happens is you need to understand your language at a pretty deep level. But again, see, we are not here to understand either C or C++ or Java. So those are going more in towards the app development. I'm not looking at app development. I'm looking at using language for automation. So many times, not many times, it's always that OOPS is definitely used as a part of that. So I hope I answer that. Okay, so now how would you become a DevOps? Okay, so this is what we get into and understand. Okay, so DevOps tools, scripting skills, coding skills, and process re-engineering skills. Now, what is that you require to be a DevOps? Okay, first and foremost, you need to understand the operations slash systems domain. So what I basically mean, you need to know system administration. Either as, I know you could be a developer who knows it, or as any other engineer, maybe a DB engineer, as a DB engineer you know it, as a network engineer you may know it, or as a Linux administrator you'll definitely know it. So this is a must. You need to know. You need to understand. You need to understand administrative operations and have that particular skill. Basically saying you need to know, understand all those commands, your LSs, makedr, and then how to create file system, how to handle your LVMs, how to configure a network for your system, whatever that may be. Everything that you need to know. So that is one aspect. No second thoughts on that. Second, so many of the system admin guys today also have scripting skills. So when I say scripting, this is pure form of understanding your bash with sed, with awk, and of course knowing regular expressions. Yeah. So this is a must to come from, because you would still use scripting skills even though you may be using one of those popular languages like Perl and other things as such. And I also want to let you know, see, primarily today, DevOps is more Unix oriented. And I can tell you, DevOps is also Windows. Though we have not seen much happening in that space as of now, but you would maybe 1 or 2 years, one year or so down the line, you will have Edureka launching DevOps for Windows and DevOps for Unix, and we are primarily going down that line. At this moment, DevOps is all about using your development skills for Unix as such. So primarily what happens, yeah, you would actually looking at DevOps Unix engineers than actually DevOps Windows engineers, because using the skills at this moment I can't apply much into the Windows space, but Windows is coming up with their own way of handling DevOps in the Windows environment, which will come much later as such. As I said, so you know a bit of scripting, and definitely you should possess at least one full-fledged language. You need to know one language, either Perl, either Python, or Ruby, and this is what is present as such. They are using one of this to actually get into the automation space. And Python at this, I think, moment probably would be on top of the three languages. So anyway, we have examples, and so Google and Amazon being the biggest users of Python in their automation space. So maybe that's one of the reason we are we hear a lot of Python and other things, but Ruby is definitely trying hard to catch up into that space. Sorry. So knowing one of these skills, so apart from knowing the skills, you need to know re-engineering, process re-engineering as well. So when I say process re-engineering here, see, we've always installed a system using a CD-ROM or any other way. Now, can I get into the space of unattended installation? Can I get in the space of unattended application installation? So you should look that into the this re-engineering in a holistic way. Example, and we've always used SCP to transfer files. Is there another way to transfer files? Okay, we understand. We understand that configuring, applying configuration to machines is just by copying. Is there another way to copy these configuration files? Is there another way to deployment? Is there another way to deploy? Is there another way to you package your own files as well? So this re-engineering skill is a must for you to really understand this whole space. Okay, so putting all this together, I know this is a lot, so I think Kishore is asking that same question, but you expect all the skill sets for the same guy. We can rather have a DevOps team, not a DevOps guy. Yeah, yes, you can have a DevOps team. As I said, more and more, you might have heard this word called left shift. So when you start with an operations, right, you have the maximum number of people. You'll have your L1s and L2s and probably L3s and architect. And as you go down the line, all L3s would eventually get consolidated into an L2, so that we redeploy them or we reduce them and then put them into another application, another way. So the whole idea of DevOps is also to reduce on people count. Though I know, unless as an example, I'll give you an example of my own experience. When I handled Unix systems way back in 2000, for every 30 or 40 Unix systems, we had one Unix engineer. Now, forwarding to 2010, for every 10,000 engineer, for every 10,000 systems, there was one guy to handle. So you can see the difference, right? So you take in a traditional enterprise world. If you had 1,000 to 2,000 systems, I'm talking about 2,000 and 3 1,000 to 2,000 systems, you definitely at least had 5 to 10 engineers managing it. But you don't see that today. And how do you how has this been reduced? This is through some automation way. Either there was a team which automated and then they handed over to the L1s and L2s to manage it, or you had just had a good DevOps guy who could handle all of this together in an easier way. So you need to have a little more skills than you otherwise had. Yeah. So there is definitely a lot of things that you would want to actually gather to be a DevOps engineer. Yeah, and he needs to know a lot of things than otherwise he would know. We see now that the kind of skill requirements that we want, should you be a DevOps engineer as such. As I said, Unix commands and scripting, your bash, your shell scripting, your coding, and now the other things you need to today add into your skill base is the configuration management systems, either Puppet, SaltStack, Orchard. Now, even I don't know all of these. I primarily, I invariably stick to SaltStack. That's been my base. But if I were to go to another place, maybe I may have to pick up Puppet and Chef. Then the other thing which you may have to know, which is, there is no second options, but you have to know is all of these things. You should understand what is PXC, what is DHCP, what is DNS in depth. So there is no second thought on that. And there are other tools like Cobbler, which you may or may not want to add into your skill base. Okay, so we hear this term continuously called continuous integration and continuous deployment. Okay, so sometimes I feel the whole DevOps is created to just to do these two things. Not these two things, rather continuous deployment. That's what we get today. So what's all this about continuous integration and continuous deployment? It's as simple as that. It's as simple as saying that we want agile development. Now, when we say agile development, what we are looking at is, as an example, I'll give you. So to imagine you are on the you are on web with one of your apps, and suddenly one of the business guys come and tell you that, hey, you know what, we need to add this feature. We need to add this feature. We need to add this feature into your website. Now, how do we go about doing it? So we know that we may have to make some changes in the back end in your DB. We may have to make some create some business code in your app layer, and then we may have to make some changes, and we have to make some changes in the web layer as well. So if it's a web app, these three are the layers that you would kind of work. And if it's another application, there may be various other things. Now you need to code this. You need to test it, and you need to test. You need to code this. You need to package it. Test it, then package it, and then deploy. Now, in a traditional way, all this would have taken so many more cycles, right? It would take more than 2 to 3 weeks and things like that to get something moving in this. But here we are looking in days or sometimes in an hours. So, example, one good example is I keep going back to that example of today all of the Amazons and the Flipkarts and the Snapdeals keep launching these deals day, right? And in a deals day, they expect so many users coming and all that. Now, for a deals day, there may be scenarios that you may make changes in hours sometimes to cater to certain demand and things like that. Now, how do you go about doing this? We can't do this through the normal procedural way of deploying application. We have to go through in an automated way. So, so the automated today is what we call as continuous deployment. And for this continuous deployment to happen, there are various tools that we are going to use. And in this situation, this the tools plus process plus some kind of development is going to come in to get this whole thing into a production deployment stage. Okay, so yeah, I mean it's pretty obvious what are the advantages of CI versus CD, right? And CD is the most fully automated way, but of course, when things go too much automated, there can also be its own risks as such. Like I very recently, Amazon lost, a couple of hundreds of servers' data wiped out by accidentally running a script. Now, so we also need to take care of that as well. So, but I know they would improve with everything, but you have this risk always with the CI and I mean, especially in case of CD as such, where everything is automated, including your testing as such. But CI works in a little more careful way, but again, you need to see speed versus time in how we want to handle it. So DevOps in real life, the Apple was one of the first companies to develop the DevOps team. But actually, what made DevOps into prominence is because of Yahoo's and Google's. Actually, they are the first to use this because their servers run into today not thousands. It's actually hit I think nearly 1 or 2 lakhs, if I'm not wrong. Definitely crossed a lakh of servers for sure. So having such huge numbers of servers, we have no other option but to go the DevOps way to do it. But have the other organizations, when I say other organizations, have the enterprises adopted it? Now that is the big market we are looking at. if we could adopt DevOps in an enterprise organization, we would then be creating a new set of space for us to and a set of skills to work on as such. So that's why this whole course has been designed, to see how we could adopt DevOps in an enterprise space. Yeah, so we all know now the benefits, right? The flexibility, the cost avoidance, the agility, which I've talked about. Accelerated innovation, yeah, may and may not be, but IT efficiency, big way. That's what is the whole mantra. The efficiency you get in the IT operation, that's unbelievable, because automation brings in consistency and at reduced cost, and that's the greatest part of it. Okay, so this is how that whole picture looks like. How the DevOps is. So so this is actually the CI/CD cycle. So we have the continuous integration, and then from there, once the package is ready, it goes to the the release automation engineers or the application deployment team, which actually manages the which probably could be the infrastructure people also. It depends on how the organization is. So there is the release automation team, then you have the infrastructure team, and the application team as such. Now, let me just before I wanted to. Okay. So if you were to split this, I just skipped a couple of slides, just to give you a little more meaningful way to organize the thought there. If you split your DevOps, right? So DevOps can be split into infrastructure automation, your configuration management layer, your CI, your basically CI and CD are kind of merged together, your CI/CD layer, and your monitoring layer. So we need tools at each of these layers to actually deploy your, actually create this the DevOps environment. So what we see, what we see here is each of these layers. Okay, so we have the monitoring, the infrastructure, CI/CD layer. I mean, of course, this is kind of merged, and you also have your configuration layer. So, again, though I'm trying to say there are 4 or 5 kind of layers, some of the layers can be integrated. So your infrastructure automation could be a combination of configuration management and infrastructure combination. Now here you see there is a CI layer and a deployment layer which is separate, but they probably could be merged. But your application monitoring is going to be another separate layer. So how each one designs, it's going to be slightly different. From my experience, we had a separate infrastructure automation layer. We had a separate configuration management layer. We had a separate the release automation or the continuous deployment layer, and we had the monitoring layer. So these were 4 separate layers, which I mean, from my experience I'm talking of. So, but this could be different for different organizations and the way they are going to use them. Some could be merged, some could be standalone. Some may only be using a configuration layer, they not be using an infrastructure layer. So it varies from organization to organization. Okay, so this is how it would look like. So what we are, expecting is, if you look at a general data center, life cycle, or what do you have? So you get in your servers, you plug the server from power and network point of view. then you image your server. Now today imaging is two different things, right? You could image it with an OS or you image it with a virtualization layer. So you image that. Then you may create VMs or you may not choose to create VMs. Then if this was a web layer, you would probably attach to the load balancer. If this was a DB, then you would need to attach your web and your DB servers. And if this was a DB layer, you may have to probably attach a SAN or things like that. So now you look at each activity that you have to do. Now all of that gets into a configuration layer, and this is what your configuration systems management takes care of. And after that, you have to deploy all your apps and then do the full integration so that your apps is ready. So so the whole lifecycle goes through provisioning, configuration, and integration in a production cycle. So I think I came here. So you now know what tools are to be used. Before that, let me check if there are any questions that are coming in. Okay, so as you now know, there are there are different tools for different layers, and this is how this whole layer fits in. So the infrastructure layer, your configuration, your integration, deployment, monitoring, and there are a couple of so the revision control, SCM, and virtualization. Though they are not different layers, they could actually get into one of these itself. So that's how the whole space of DevOps tools is all about. So by now, I think you're clear with what the continuous integration and deployment is all about. So, so let me tell you the Puppet. See, Puppets and the likes. So it is going to be Puppet, SaltStack, and Chef, and there's Ansible, which is also another popular. Now, these particular tools will come in only after the operating system has been installed. Because for all these tools have a client-server architecture, and if it's in a client-server architecture, there is an agent which gets into all your systems, and there is this Puppet server. Now, this can be only installed once your operating system is installed. So that is why I'm saying there are layers. Now, why I say there is an infrastructure layer is why I say there is an infrastructure layer is infrastructure layer is the layer which installs your operating system or your hypervisor. So I need to be very clear with it. It installs your operating system or your hypervisor. Only if this is installed and configured can I then start with your Puppet. Without these two, without the infrastructure being in, I cannot bring in Puppet. So that is why there is a clear distinction between the infrastructure layer and the configuration manager. Now, using Puppet, I could further install other applications like your Apache or your MySQL or maybe or your any message queue server. And then further, I could deploy my applications itself. So, but all this will come post your infrastructure layer, and that's why we are separate here. So once this is deployed, once your applications are deployed through your Puppet and stuff, the next thing is you need to monitor them. Now, how do we monitor? So, monitor, we have a separate set of infrastructure. Now, this is one of the most important aspects of DevOps. And I will come back to that example which which I gave in the webinar, and let's see how this monitoring plays in this whole layer. Okay, so let's take this again, this example of okay. I mean, instead of going to an e-com, let's get into the example of today. Today there's a cricket going on, right? And you would rather expect some standard set of users trying to log into the one of the sites, maybe ASPN or whatever that may be. Suddenly, because of some activity within the cricket field, the number of it surges, right? When it surges, we all know everything has been designed for some number of users and etc. If there is surge, the surge cannot be handled. Correct? It can't be handled. So people are in. This is what happens. People will be like, if you've been booking IRCTC. I mean, if you're booking a rail ticket through, you all know that how you get into the queue on a Tatkal day. So that's exactly what would happen in a website. Now, how do you handle such a situation? Now, in this situation, what DevOps would do is, first, I would create a new VM. I will provision a new VM. Then I will configure that. I will use Puppet and install my application. Then I will connect him to the web, to a load balancer. I will connect him to a DB, and then bring him online. Now, all of this is happening without you interfering. Now, how do you make all these things to happen? So I use the monitoring layer. The monitoring layer will tell that the number of users at this moment is gone beyond for the infrastructure to handle. If this was designed to handle 1,000 users, we have already 1,100 users. Now I cannot do it. So the monitoring layer then goes into the backend system and triggers an event saying that the users have gone up and we need to build a completely new system to handle that many users. Now, how do you do this integration of event when a monitoring agent triggers an event? The event goes into the infrastructure layer. It creates a VM. It creates a Puppet. So you know, this complete pipeline has to be developed by these DevOps engineers, and that is why I again now say I give you another use case where you require strong coding, you require strong networking, and understand this whole integration, how this is happening. Okay, so I hope now you could get a better picture about how this whole systems are integrated now. Yeah, can I install? So Habib has a question. Can I not install Windows or Linux OS using Puppet? Okay, here is the question. So here is the answer to that, sir. Operating systems for bare metal needs to be provisioned through the infrastructure software. When I say infrastructure software, that includes PXE, DHCP, and your Kickstart utility tools. So a bare metal can only be provisioned that way. But if you are thinking of provisioning and always using Puppet, then we are talking of the virtualization layer. So your hypervisor needs to be installed through a infrastructure automation layer, whereas your VM can be installed through your configuration management layer like Puppet. So that's how you differentiate here. Hope this is making sense. Is that I mean, this is a very good question. I think I probably skipped while answering this whole situation. We need to make it clear where you position your infrastructure layer and where you position your configuration layer. Okay, so now mindset, the DevOps challenges. Yeah, DevOps is not easy to implement in an enterprise, but in an internet organization, that's there by default. We don't have a choice. getting this into an enterprise is a bit of a challenge because of various things. One is the technical challenges. People are even today. I mean, when we see when do you get DevOps? I'm sure if you have gone through an infrastructure life cycle, you know today all organizations are consolidating. Right, we hear the word we are consolidating our data centers. What do you mean by consolidating our data centers? When we say consolidating our data centers, that means we are actually bringing down the complete server footprint and having them virtualized. So when we virtualize, you are invariably reducing the server footprint. So consolidation is about virtualization, and then once you virtualize, you have the next stage. That is the automation, and that is where the DevOps come in. So where are we today? So today, a large, I think 70 to probably 80% in US have consolidated. Have their data center consolidated. That means they have virtualized their environment. So once the environments are virtualized, the next step is nothing but automation, which is nothing but DevOps. But is DevOps immediately necessary in an organization? May or may not be. And that is where we need to push people's mindset to start saying that this brings in a lot of change. But as I said, see, this also, momentarily, it also reduces the people usage. So because of which there are going to be a lot of challenges. I'll give you examples. When one of the very big pharma which I worked, it was a predominantly a SunSpark platform, and it was all Solaris, everything about Sun you would find in that organization. One day, the head of IT changed, and he happened to be an ex-IBMer. So this guy decided, yeah, I will just go in for complete IBM. I want to change all of this. Now, when you take such decisions, the internal people who were all trained to be on Solaris for so many years did not just like the option of going into a AIX platform. Now, so you see that there was tremendous challenges which you would come into such a kind of, and you kind of face that in DevOps as well. Because people invariably perceive this to be loss of job. See, momentarily, yes, it looks, but I'm telling you, this creates another opportunity in so many other ways. When I say when DevOps is coming in, that doesn't mean your system skills or server skills or storage skills are going away. They are not. But you need to reskill to be relevant. That is more important. So why is automation? So Habib had another question. Why automation is not possible without virtualization? Automation is definitely possible automation is definitely possible with virtualization or without virtualization. But what is the difference is the agility what you get with virtualization is much more than in a bare metal form of automation. So as I said, having worked quite a bit on the Sun side of it, we had all these automations during the bare metal phase itself. We had a lot of them. But of course, I can't, see, if I have an operating system installed on a server, can I move that entire operating system to another server if that system were to crash? Now I can't do that because I need to remake that entire OS and put it into another machine. Now imagine if that were to be in a virtualized mode. I could move that operating system seamlessly across different machines because there's nothing going to stop you there. Okay, so this is what This is what is whole thing about automation in a virtualized space as well as non-virtualized space. Hope that answers Hadi. Okay, so very clear. Very clear. So there is a DevOps culture that needs to be brought into people. There is processes that need to be into DevOps. What is the process? I think we talked about this in the beginning. Where is the dev team and where is the op team and how are they all coming in together? So that itself is a big change. So ITIL, the infrastructure information library process, which I use for process management, will be changed to do the DevOps stuff. So because ITIL works in the traditional IT format, we need to change that to make it in the DevOps way. So that is, and technology, yes, we need to have, you know that by now, there are so many tools that are going to come in, and you know the different layers that are there. So, so there's a whole set of technology, and again, as I said, we are all talking of DevOps in Unix plane. There is a completely different set of DevOps in a Microsoft plane, and that will be the next step where people who want to get into it. Okay, so yes, the transition, there is fears, there is risk. I think we all know that, but it is important for people to identify where. So this is all about the theory of constraints, which I talked about. As a infrastructure guy, you would need to understand where your constraints are. Once you know that, you can simply adopt your DevOps to remedy those bottlenecks, and that's the whole way of adopting DevOps. Know your constraints and see how do you automate that stuff. Okay, so again, we know we need to have the right tools, the right culture within the system, and of course the team which earlier operated in silos would now have to be together. So that means you have your operations team, your dev, your QA, all of them coming together to get this going. Okay, so now yeah, we are again speaking about time. So I think now by now you would know how to go about doing a DevOps transition. And as I said, the starting point for DevOps is application consolidation. When I say application consolidation, it is consolidation to a virtualized infrastructure. Once that is in place, then the next step is to see where are your pain points and how to get. So in one of the easier ways to start is like everybody 3-4 years earlier or even 5 years earlier would if you were to be a backup engineer or so, would go and manually check if the backup was done or not, and then send a report to the team. Now, why do you want to be doing all this? Why don't we automate this? This is the first step. Okay, now like this. So like this, we can various admin processes that you do can first be automated. Once you do this individual automation, then you get into the larger picture of bringing in a configuration tool like Puppet and so, and then you slowly you would then have various pieces automated, and then eventually you actually become a DevOps environment. Okay, so now understanding the infrastructure layout. So as I said, to get into the DevOps, we need to understand a lot of these infrastructure stuffs. What goes into delivering a complete solution for an application from an infrastructure perspective. So you should understand. So normally all of these web applications would go into this idle architecture of there being a load balancer, okay, behind that there being a web server, and behind that there being a DB server. Now, why do you have a load balancer? A load balancer is there. See, you need to know about your high availability, and people talk so much about high availability, your DR and various things like that. Okay. So what does load balancer do? Load balancer addresses the web layer's high availability needs. Then you have a cluster. What does a cluster do? Cluster addresses your high availability needs of a database. So this way, you need to understand various of these infrastructure applications which gets into these things. So that is why knowing your infrastructure becomes a very important criteria to get into the development. So it's not that if you do not come from a background, I can't adopt it. Absolutely not. If you don't have a background, you can always come in, because these discussions will always happen even in a dev environment on how the infrastructure itself is. Okay, so hey, virtualization is actually what brought in DevOps into the storm I talked about 2009. So I know virtualization existed even before that, but the concept of virtualization, brought this notion of OpEx-based operations. Earlier we had CapEx-based operations. So what is this CapEx-based operation? Earlier, if you had to buy in a server, we put in the code, look at all the vendors, and then it takes the idle 2 to 3 weeks of getting it right. Now that is not the case. Today I want a server, just get into AWS, Azure, IBM Software, log in, create your VM, and you're good to go. So so can you see the speed with which I have provisioned a server compared to the CapEx-based operation that we had earlier? So virtualization is that software which brought in this concept of CapEx-based operation. Every organization adopts, as I said, the consolidation. It adopts some form of virtualization. So it could be a VMware path, a Red Hat path, a Red Hat KVM path, or a Microsoft Hyper-V path. Invariably, it's one among these 3 layers. Now, one thing I did not tell you is, and which adds challenge to the enterprise world is, if you look at organizations like Yahoo's, Google's, LinkedIn's, and probably even Amazon's, they have a homogeneous environment. What that means is their servers are identical, their hypervisors are identical, so that now to do DevOps here is so simple, because we know there is a consistent layer across network storages and your servers. But if you look that from a enterprise level, there is no homogeneous. It is a heterogeneous environment. Your hypervisors are different, your servers are different, your networks could be one side Cisco, another side HP 3Com product. So now the challenges in enterprise for DevOps is far more than in an organization like the internet companies. Now that is one thing which you need to keep in mind, and that's where the complexities come in, and you need to know much more how to integrate a heterogeneous environment. When I say heterogeneous environment, it is servers are different, your virtualization is different, your apps are different. Everything is going to be different, and you need to integrate all of them together to do okay. So the DevOps itself, the concept itself may change a little bit there, the way you're going to. It could be more of an automation and less of a true DevOps work. So there was a separate configuration team, and there was a separate ops team. So, and I was saying, in an internet organization, this would not be the case. They would be the same. So why that particular organization had this stuff is because of the heterogeneity requirement. And that is why you had a separate operation team and a separate configuration team, because the complexity has been much more there. And I'm sure the virtualization also would be different. And that is why you have separated. So the DevOps slightly would change when you get into the enterprise world as such. Okay, so I think I talked about all these, the virtualization. So I said the three popular ones, your VMware, Hyper-V, KVM. And then without this, we are not even trying to get into a DevOps phase. We need this there in the first place. So scalability and availability. Scalability, and I think we addressed availability through load balancers and clusters. Now, what is the scalability? See, today, Facebook, your Facebooks, your, for what I know, your Facebook, Yahoo, your Google, you know what they do? They design their own servers itself. They don't use any of the branded servers. They design their servers and customize it into the way they want. So invariably, they'll all be an x86 based architecture platforms, but they design. So what do you mean by design their servers? I'll give you an example. So which you might be knowing. Now, if you take one of their servers, the whole power consumption of an equivalent server in enterprise will be at least 10, 20, 30% more than what they have. Now, and how do they achieve? They achieve by various things like, they will completely eliminate all these unnecessary ports like your USBs, remove your CD-ROMs out, remove your keyboard ports, remove your mouse ports, and other ports as such. So they literally redesign the servers, and the only interface to these servers is going to be through what is called as a system console or system port. That is a standard Ethernet port through which you will get to see your complete hardware through that port, which you don't find in a traditional desktop box. You will find these in the. So this way, first they have removed all the unnecessary components from the servers and they have customized it, and basically solve for power reduction and nothing more. And all of them, I hope you understand these words, 1U, 2U, kind of these terms called 1Us and 2Us for servers. All of these servers are in this range of 1U and 2U kind of series. Why do you think these guys design their own servers and they have their own own set of tools to manage it? It's because all the traditional servers, they're kind of designed more for vertical scaling than for horizontal scaling. So let me talk about what scaling is all about in the first place. So what is vertical scaling? Vertical scaling means adding resources, hardware resources within the system. That is, add more CPU, more memory, more disk, more network. But within the system will have to grow to accommodate those requirements. Now, if I can't scale vertically anymore, I would need to add another server. All internet companies have completely discontinued this process of scaling. They have what is called as horizontal scaling. So in horizontal scaling, we do not add resources internally. It is when you want to scale, we just keep adding boxes. Now you may think that adding boxes, you're actually going to increase the power usage. Yes, we do, but the advantages are much more, because all vertical scaling devices are very complex to manage, and if they fail, then the consequences are so much. Now, what happens in a horizontal scaling system? If a box fails, I won't be worried, because it is just one among the 100 boxes which is failed. But in a vertical scaling where there are only tens, failing one is a big problem. Whereas in horizontal scaling, where there are thousands, failure of one does not impact my performance. Okay, so this is about your scalability and how these systems are to be architected. And so I should tell you, now when you're designing applications, and since many of you come from app development platform, so we have the web layer, app layer, DB layer. Very easy to scale your web layer and app layer. Just use a load balancer, we can scale it, right? But can you scale a DB layer like that? Can I put a load balancer in front of MySQL or an Oracle or a Postgres and scale it? Now that has been the challenge, right? We can't scale it. If you want to vertically scale, you would need tools like Oracle Rack or so. And that is the only way we can scale it. We can't scale otherwise, right? Now, that is where this whole concept of NoSQL has come in. What does NoSQL do? It helps you to scale horizontally. NoSQL databases help you to scale horizontally, just like how you would have scaled in a web layer. If I want more people connecting to my web, I just need to put a server behind a load balancer, and that's it. I can handle them. But can I do the same with my DB level earlier? I couldn't. But now with the NoSQL coming in, I just need to plug in a NoSQL server and it starts scaling. And it is as simple as that. So I hope you are getting these. If you have any questions, stop me, and I can answer you all of this, because these are all something which I've done quite a bit. And anywhere, any questions, please let me know. Okay, so I think we've answered all of these. We've answered, I told you scalability. Scalability is at web layer, app layer, DB layer. Okay, so one form of solution earlier to scaling was to cache. So what is caching all about? Caching was all about putting all your data in memory, than having it stored in your hard disks, right? So today, see now, I mean, coming to these hard disks, that's another interesting aspect that, you know. Now, we always had HDD, your hard disk drives, right? And then today they are slowly getting replaced with your solid state devices. Now, what is the performance difference that these SSDs get in compared to HDD? It is actually, in, you know, it's 100, 200 times more than what the performance an SSD gets in is 100, 200 times more than what HDD would get. As an example, see, we use this term called IOPS, input outputs per second. Now, very high-end HDD, which you find in which you find in servers like your databases, can handle at most close to 200 IOPS. That is 200 input outs per second. Now compare that with a SSD. It can go from anywhere between 3,000 IOPS to even 10,000 IOPS in a single disk. Now you see the difference there. It is so much of a difference that we get into this stuff of your disk. So in scenarios like that, caching, you know, can be, I mean, because your hard disk itself becomes like a cache. We don't require another set of memory to handle these things. But that said, caching is still not a solution. I can cache as much as my server physical limits allow me. Beyond that, I would need to get in another server if my requirement goes beyond that. Continue with the scalability. Now there were other options. One we saw was caching. The other is what is called as CDNs, you know, content directory networks. Now what are CDNs are? CDNs are localized web servers. So that means, imagine you launch your application in India, in a data center in India, but you do not want a user in US coming right up to a server in India to access your application. I would prefer a localized server in US which would handle this stuff. But I don't want to move my databases and other requirements, other things to US. It's only that first page hit. The first page hit I would want to be localized, and that is what your CDNs do. Okay, so availability. I think I spoke about various levels of availability. You would have a load balancer, as I said. You would have a cluster software. That is one way. Else, you would have a replication. That is another way of doing your high availability solution. Else, sometimes your high-end systems had what is called fault tolerance levels. So those were, these are very high-end systems where you had fault tolerance at, when I say fault tolerance, I had high availability within the hardware itself. So that was called as your fault tolerance. So I hope you get all the options of your high availability and fault tolerance. Okay, so I suppose now you kind of understand various of these layers. You understand what your caching, your load balancer, servers, network, and then I'm sure these are all kind of a bit obvious at this point in time now. And so this is a complex. I mean, of course, see, this is something which we are not going to work. It's only for our understanding, because this is something the network team does. But we need to know. But we definitely do work with the load balancer many of the time. But that's most only in the development side of it, not in the production. Production, your load balancers, network, your switches, routers, we do not touch. You'll have a separate team who's going to handle all of these things. Okay, so yes, apart from the general obvious thing we generate, there's also this firewalls. Okay, so firewalls will also come in, and again, firewalls on the peripheral network, or when I say peripheral network, these are the firewalls on the switch side and your load balancer side. Again, we do not touch them. It's only for our understanding that these tools are there. As a DevOps engineer, we don't touch them at all at any level. But we need to know, we need to understand how this whole systems communicate, and that's the essence of putting this particular here. Okay, so load balancers. So understand, in a very simple terms, load balancers are a way to get high availability for your web layer, and it is as simple as that, and nothing more. So load balancers work in many ways. There are L3 DSR, L2 DSR, some work at the kernel layer, some work at the user layer. There are various ways that come in. So, but many organizations today, instead of investing money in appliances like from Citrix and other vendors, they use servers like Nginx and a web server to use as a load balancing or a proxy layer, or sometimes they use what is called as HA proxy, which is also prominently used now. But other companies use appliances because that they feel is more faster, which is also true in a large way, and they feel that's more secure again, and that's also true in a larger way. So load balancers are a very important component. We tend to interact with them a little bit, but of course, the control is still with the network team, and we do not still have much control over that. And of course, all your servers are kind of designed for various levels of operations alone, right? And you can always get the IO bound errors, CPU bound errors, out of memory errors. So one big aspect of a DevOps engineer is performance engineering. Okay, now that needs to be come in a big way. So you need to know how applications perform in your given system, and you need to know at the core level of how you would actually handle each of these tools to understand how your CPU is performing, how your network is performing, how your memory, what's your stress on your memory, what is your service times of your IOs. Yeah, these are things that you need to handle. Okay, and apart from understanding it, so you also need to, that's why I said you need to understand a lot of applications. You need to understand how your database works, how your Apache server works, how a middleware works, or even, to some extent, how even a single sign-on works. Because it's only then when you get this big picture can you actually do DevOps in a very right way. Else, if you don't get that big picture, your DevOps will be half done. So you need to know all of these. Understand what is network socket. What do you mean by this word called session? How is a session created? So you understand your network components, like what is SYN, ACK, what does that mean? What is a wait, timeout, wait 1, wait 2? Now these are things which you see when you create a simple. So that means you should be able to write simple sockets in either a Perl or a Python. How do you create a socket server? How do you then use a client to connect to it? How you can pull data from a server or push data into server? I mean, you need to have a basic understanding of this. This is very important. Only once you understand this, you will understand your network in a very deep way. Okay, so caching layer. Yes, there are a lot of caching layers. Your web caching, your DB caching. And there may be other layers as well. CDN is also a kind of a caching layer, as I said. So caching does improve tremendously, but I said there are limitations because you can't keep caching forever. There are physical limitations on how you can cache. Okay, so Google is the master of scalability, yes, and they do horizontal scaling. Okay, their goal is always to build higher performing, higher scaling infrastructure to support their product, and they all scale horizontally. And the languages they have been using is Java, C++, and Python. So I said Python goes in the DevOps layer. Your Java and C++ go into the pure dev layer. So that's how they have kind of organized it. Of course, there are other languages as well. They've also developed their own language as well. Okay, so I mean, any idea what could be the number of servers today Google is having? Actually, they run into 1 or 2 lakhs, or even the estimate is that it is around 4 lakhs. So that is the kind of servers they may have. And the great thing is now to increase further, they need not always increase number of servers. They may reduce it with other better optimization coming into each of these. As I said, they design their own servers as such. Okay, so they have nothing but commodity servers, thousands of them. They have a file system. So if you know of Hadoop, then there's something called HDFS. So equivalent to that is something called GFS. So they use that file system. Okay, so the aggregate read and write as hundreds of gigabytes per second, petabytes of data. I mean tons. Tons and tons of data they generate. So they have various ways to handle these tools as such. Okay, so YouTube is another. YouTube I know is again MySQL, and look at here again. There is Python. So that's why I was saying that Python, Google made Python the popularity it has today is primarily because of Google as such. And nowhere they will use any branded product. It's all open source, and open source further customize themselves. Okay, and these are the rough statistics that you may get, but what is important, 2 sysadmin, 2 engineers, 1 DBA handling so many users. So how do you get in such kind of optimization? It's only because of DevOps and nothing more. Huh? Okay, and so today it can be handled in many ways, and Facebook is one guy who has you get into a lot of mobile, a lot of tabs just apart from your laptops alone, and they also have the same thing of high scale and a great set of DevOps team to handle as such. So just a question. Hello there, my name is Annie. I love quizzes and puzzles, and I need to make you guys think and answer my questions. Okay, what are the lessons learned from the use case? Infrastructure can be competitive advantage, build self-imaging, self-managing systems that work without having to take the system down, keep things simple. So what is the answer to this? So your questions are also there in your thing, and yeah, there is of course the answers. So the answer here is going to be all of the above. So these are the general questions that you want to answer. Just take up them, just do a refresh and see if you are able to answer them. And any doubts, just let me know. Okay, so that's the answer. And networking concepts. So as I said, we do not need to work at the networking layer at all. That is switches, routers, your load balancers, firewalls. But we need to know them. We need to know them how they work, and that is why these slides have been added. We need to know what is a TCP packet, what is these. I mean, I'm sure you know a lot of this word called NATing. You use a lot of it. How the NAT performs, how the NAT works. So these are all important concepts. You need to understand what is this MPU means, and how that is important in your loading your first index page. So these are things which are very, so conceptually you need to know all of these things in a very detailed way. Understand what you mean by a broadcast domain, what is a collision domain. So these are a concept which you come out of a switch, come out of networking. So switch is always in a collision domain, whereas router will isolate your collision domains into more of broadcast domains. Okay, so these are the concepts that you would, kind of need to refresh and come back as you become a DevOps engineer, because you need to know how all these kind of things work. Okay, so your switches. So what are these layer 2 switches? What are the layer 3 switches? So layer 2 switches means it is your traditional switch layer, it is a bridge. And when you say a layer 3 switch, that means it is a switch per se, what you actually see here. Okay, so you need to just understand. I mean, it's not about operations. Understand what are these ports, what do you mean by layer 2 switch, what is a layer 3, what is an OSI layer. You need to just understand there, because that's where it is. And okay, I mean, these are the network of switches, not of much of a consequence for us personally, but just to know. Okay, as I said, we need to understand all of these. We need to understand what your firewalls are, how your routers are connected, how your load balancers are going to be. So it's all about, you want to know how your load balancers are. Once you want to know all about your load balancers, indirectly you need to know to which switches it is connected, to which port in the switch is connected to, and how the switches are backend connected to routers. So this layer is something which everybody should understand as a DevOps engineer for your better automation and things like that. Okay, then again, getting into your networking, you need to understand what are these IP address classing, what is network bit, what is host bit, what is class A addressing, what is class B addressing, and C addressing. B, D, and E are kind of inconsequential. We don't use them. And what is the network bit? What is the 24 bit? you don't have to, be working with them. It is good if you can work with them, but you understand. So network bit, so a given IP address, like example 192.168.1 dot some 10 or something like that, will have a network portion and a host portion. Network portion dictates how we should get into the particular network, and the host portion points to which is your particular host itself. So you need to understand what is your subnet mask. So subnet mask is used to isolate your network portion and host portion in a given IP address. So these are things that you would need to actually know. Okay, and you should kind of, I mean, this is too much of a theory though, but you just understand what is a packet. What do you mean by a TCP packet? What do you mean by a UDP packet? And understand what you mean by a port. We all know what is a source port, what is a destination port, because these are very important when you configure your load balancer. As I said, you don't do it, but you need to be telling what kind of ports your applications are working on. So that the the network engineer knows what ports to open, what ports to close, what kind of ports are getting. So you need to just roughly understand. What are these? You may want to know what is a sequence number, what is an acknowledgement, what are these flags. Okay, so I talked about what is ACK, what is SYN. I know this is kind of getting into the network space, but it's just good to understand. Just good to understand. But this doesn't stop you from being a DevOps engineer. You would invariably be forced to learn this once you are into the field, because you just want to understand for your applications to perform better, and that's all about it. Okay, so we kind of don't have much of a hands-on in this, but we just need to understand what is a route table and how a node talks to a node, what is a table and things. But again, these are a little bit on to your networking space. So as such, you don't have to worry too much, but it's just that it's a little good to know. Okay, and a little bit on these one-liners for all these. What is RIP, OSF, OSPF, and BGP, and etc. These are all routing protocols. So one-liners of that would be more than enough, and nothing more. You can just see that and come. And there are a lot of references that you can actually check. Yes, more of reading material, and you have some assignments. You can actually just go through them. It's in your link. Just download them and answer. Okay, so Cacti, if I'm not told you, is another monitoring service, just like your NatGeos and various Xenoxes and things like that. So it's one of the monitoring tools. So you can just go through these. Just go through your assignment and get the answers to these. So for the next class, get all these DNS, SSH, FTP. Understand them. What does DMZ mean? And I'm sure most of you already have many of these skills as such. And understand a bit of network, and I'm sure the operating system, most of you understand. Okay, so what is the agenda? You need to core understand your DNS, you core understand your web servers, you core understand your load balancers, and you understand your storages, understand your proxies, and so we get into hands-on of all these things, and that is what you need to get to do in your next class. I hope with this session you are able to kind of understand the role of DevOps and how they fit into the whole scheme of things. I hope this class should have kind of clarified then, I suppose. Thank you for coming, and we'll catch up tomorrow.